All right, checkpoint exercises for square roots and cube roots. With problem 1, we have the square root of 484. And again, this might not be one that is recognizable as far as it being a perfect square, but it is. If you actually go through and try to, by trial and error, find values near here, you'll see, well, we should know that 20 times 20 is 400. So we know it's bigger than 20. 21 times 21 is too small. But then if you try 22 times 22, you'd see that it is 484. So we know that this equals the square root of 22 squared, which simply equals 22. Same thing with the number 2. It might not be recognizable at first. We do see the negative sign on the outside of the radical, so we know that we're going to have a negative answer. And again, by trial and error, or you could just go with 441 to try to see. And if you tested the numbers for the first problem, you might have seen that 21 times 21 is 441. So 2.1 times 2.1 equals 4.41. So we know that this is the same thing as the square root of 2.1 squared. Don't forget our negative sign, and the square root of 2.1 squared is simply 2.1. So the negative square root of 4.41 is negative 2.1. Now we'll move on to cube roots with negative 512. Again, we know that the answer is going to be negative because it takes 3 negatives to make a negative. So with negative 512, again, by trial and error, you might not recognize right off the bat that this is a perfect cube. But by trial and error, you would discover that this is negative 8 times negative 8 times negative 8 equals negative 512. So we have that this is the cube root of negative 8 cubed, which simply equals negative 8. All right, again, with number 4, we have a fraction. We're looking at the cube root of 343 divided by 512. Well, 512 we just did in the last problem. So the simplest way to do this, again, we will learn eventually that this equals the cube root of 343 over the cube root of 512. Just a different way of looking at this that I think simplifies it. When you have the cube root of a fraction, or square root of a fraction, you can take the radical for the top and the radical for the bottom. So for 343, you might even remember this from one of the examples, we know that the cube root of 343 is 7, because 7 times 7 times 7 is 343. And from the last problem, we know that the cube root of 512 is 8. So the cube root of 343 over 512 is 7/8. Number 5, we have another volume problem. We're given that the volume of a cube is 42.875 cubic feet. 42.875 cubic feet. And what we're asked to find is the length of each side. So we don't have to find the perimeter this time, like in the example, but we do want to find the length of each side. So we have s cubed. The length of each side is s. So length times width times height is s cubed. And we have that equals the 42.875 cubic feet. So if we take the cube root of both sides, we have s on one side equals the cube root of 42.875. And again, you might not recognize that right off the bat, but with trial and error, you should be able to see that equals 3.5. So this is the same thing as the cube root of 3.5 cubed. So the length of each side is 3.5 feet.